Write the term indicated in the expansion of each of the following expansions. A, write the fourth term in the expansion of 1 plus 2y power 7. So you say the t r plus 1 term is given by n, choose r, a, n minus r, b power r. Now we are told that it's a fourth term, so it's t4, meaning that r plus 1 is supposed to be 4, and so r will be 4 minus 1, which is equal to 3. So this is equal to 7, which is n. N is always the power, and then 3 because we have calculated the value of r, and then a is 1. 7 minus 3, and then b is 2y to the power 3. Notice how I put the brackets there to make sure that 2 and y are all under the same power. So that 7 choose 3 multiplied by 2 to the power 3 is 8, and then y power 3. So we can calculate what 7 choose 3 is. In case you're good at forgetting, it's 7 factorial over 3 factorial, 7 minus 3, which is 4 factorial. You go down and say 7 by 6 by 5 by 4 factorial over 3 by 2 by 4 factorial. The 4 factorials will cancel each other, and this 6 will cancel the 6, so we get 35 there. Come back here and say 35 by 8 y power 3. A serious student will always find this, that 5 by 8 is a very small number. When you're looking for marks, you can easily get there. This means that you can find the 5th term, you can find the 7th term, meaning you can answer B and C, and then do the constant term in Conrad. What is happening? Let's go to, so B, no, not B. B is similar to this one. You just change the R and the N and your A, B there. Find the 5th term, the 7th term. Maybe we can do D, which has the constant term. Constant term in x power 1 over 4 minus 3 over x power half to the power 8. So to find the constant term, again, you use the same formula, the t r plus 1, n choose r, a, n minus r, b r, n 8, r unknown, a x power 1 over 4 to the power n, which is known, minus r, b negative 3 over x to the power half, everything to the power unknown, which is r. Then you put together the variable x. So collect all the x's and put them under the same power. So we'll have a work here to do 8r, and then x is to the power 1 over 4 multiplied by 8, you get 2. So what happens is that you get the power of x, this whole thing here. Simplify it. So you say 1/4 multiplied by 8 minus r. This is going to be 2 minus 1/4r. So you have 1. So we have 2 minus 1/4r multiplied by, you extract -3 from r, from x to the power half, and then take the half up by giving it a negative power multiplied by r. So you guys understand that whatever is in the denominator can go up by making its power negative. So that now we have 8r and then -3 to the power r has nothing to do with x, but we have x to different powers. So we put those powers together. So add and get 2 minus 1/4r minus 1/2r. So what we are getting here is 4 down. So we have 8 minus r minus 2r, meaning that we have 8 minus 3r over 4. So the power of x has become 8 minus 3r over 4. Now to look for a constant term, it is as good as looking for a term independent of x, because a constant doesn't have x. So what you do is you get the x that you have in your question. You know that for it to be a constant, for a term to be a constant, it must not have, the power of x must be 0, because x power 0 is 1, which is a constant. So it will just multiply with the other constants that are there. So we ensure that 8 minus 3r over 4 be equal to 0. So that here when you cross multiply, you get 8 minus 3r is equal to 0. So you can see that 3r is equal to 8. When you divide by 3, you divide by 3, you get that r is a fraction. Now when r is a fraction, it means that there is no term, there is no constant term. So just where there is no constant term. That is your conclusion. So whenever you try to solve for r and discover that r is coming out as a fraction, then you know that there is no such a term that will be constant, a term that won't have r. Okay. So what we have done here is what you do when they ask you to find the term independent of x. It's the same question as this one. So similar to finding the term independent of x. Like that. So that we go to question 7. Okay, we are found on question 7. This is a very important question that one needs to understand. Find the term independent of x in the expression x squared minus 3 over x to the power n. So let's do for b when n is equal to 12. So you write your expansion is supposed to be this. The value of n has been given. This means that our t r plus 1 is going to be n r a n minus r b r, so that it becomes n, which is 12, r unknown, a x squared 12 minus r negative 3 over x to the power 12, giving us 12 r x 24 minus 2r negative
to the
3
power r.
Where's the
Negative
power?
3 over x to the power r.
Okay, good. Negative 3 over that to the power r. Thank you. So we have negative 3 to the power r, and then x negative 1 to the power r. So that thing becomes 12 choose r negative 3 power r, and then we put together the powers of x, so we get x 24 minus 2r minus r. At this point, we extract x 12 minus 3r. It must be equal to x power 0 because x power 0 is independent of x. It's a constant term, meaning that since the bases are the same, 12 minus 3r should be equal to 0. So negative 3r should be equal to negative 12. Divide by negative 3, divide by negative 3, you get r is equal to positive 4. So you come back and say my t4 plus 1 is equal to 12 for negative 3 power 4. There's no need of substituting in the x because you already know and you're sure its power will be 0, so it won't exist. So you calculate 12 choose 4, and then negative 3 power 4, this is 81. Then what about 12 choose 4? For those who have difficulties in calculating, we help you here. So you move from 12, 11, 10, 9. When you reach 8, you stop there, so that this 8 down can take it, and you reduce 4, 3, 2, and then the 8s go. Then 4 and 3 can take away 12. 2 can reduce 10 to 5, and so you get 55 by 9. 55 by 9, that is 45. That is 45, remainder 4. Another 45 plus 4, that is 49. So we get 495, if there's no mistake there. Okay, so you get 495 multiplied by positive 81. So if you're looking for marks, you can find this.
Sir,
Hello.
where has 24 gone?
There was 24 at some point. Where has 24 gone?
24 minus 3r. Yes.
I also don't know. The only thing I'm able to see is a 12, but how come? So here you're supposed to have a 24. Ah.
This sir.
Hello.
Here we have a 24.
Yeah, I've noticed.
Yeah.
Okay.
So what? Yeah.
So, so the other parts are okay. So this is, so just waiting for R. Okay. So let's go back. So it's like where we, so we need to get x 24 minus 3r to be equal to x power 0. So it is 24 minus 3r, which is equal to 0. So 24 is equal to 3r, divide by 3. divided by 3. So R is equal to 8. Okay. So it's not T4, but T8 plus 1. So here we'll have 8. And inside here, we'll have 8 as our R. Then things changes now. When it is like this, normally it's left like that because -3 power 8. That is 81 times 81, but you can calculate 12, 8. This is 12, and this is the same value because it will be 12 factorial over 4 factorial, 8 factorial. So you get 12 by 11 by 10 by 9 by 8 factorial, 4 by 3 by 2 by 8 factorial. So these will go, and then these will cancel there. 3 will reduce 9. Which one has cancelled? 4 and 3 have taken away 12. Okay.
Why have you cancelled the 2 as well?
It's cancelling in 10, reducing it to 5. So it will be 2. We found this value. 11 by 5, 55. By 9, it was 4. It was 459. It was 490. Remember that it was 49. It was 495. Multiplied by 81 by 81. Okay. That's a term now. So you can easily get that term there. But when numbers are big like this and you have less time in the exam, you can leave it anywhere for as long as you have found the value of R and substituted it. Okay, this was question 7. We can freely move to question 8. Question 8. The first 3 terms in the expansion of 1 plus kx power n. So the first 3 terms are given as 1 plus 14x plus 84x squared. So only the first 3 terms are given. Find the values of the constant k and n and the coefficients of and the terms. Oh, this question is just asking us find the value of k and n. So what you do is you come down and say, okay, I know how to expand this. This is just 1 plus n multiplied by kx plus n minus 1 over 2 multiplied by kx squared. We're interested in only the first 3 terms. So for sure 1 is equal to 1. So this one we are done. So this means that nkx should be equal to 14x, telling us that nk should be equal to 14. And so k should be equal to 14 over n. So we keep this. So that the third term also n minus 1 k squared x squared over 2 should be equal to 84 x squared. That means n n minus 1 k squared over 2 is equal to 84. If you cross multiply here, you'd get that n minus 1 k squared is equal to 84 by 2. That is 8, 16, so we get 168. Now the reason why we solved for k here and not n is because k only appears once, so we just have to substitute once. This is going to be n minus 1, where there is k, we take 14 over n square is equal to 168. Expand, so we have n squared minus n 14 squared. I don't have these numbers in my head. So I square 56, 4, 1. So 6, 9, 1, 196. So I have 196 over n squared is equal to 168. Then you can see that this guy breaks there, and when they meet with this one n remains down. So we have 1 minus 1 over n being multiplied by 196 is equal to 168. We divide by 196, we divide by 196. So we have 1 minus 1 over n is equal to 168 divided by 196. Let's look for a number that can go in both without giving us difficulties. Let's try 7. 7 can go in 16 twice, giving us a remainder of 2. 7 in 28, it goes there again 4 times. Let's see if it goes down. 7 in 19, it goes there twice, remainder 5. 7 in 56, it goes there 8 times.
8.
Good. So this number looks reducible again. So we have 1 minus 1 over n is equal to, which number can go in both? 3 in, not 3, the same 4. 4 there, 6, 4 down.
Which is equal to,
Is it?
which is equal to 1 minus 1 over
Yes.
n. 6 over 7.
So we get this over n, so that we have 7 down, 1 is equal to 1 over n,
6 over 7.
giving us n is equal to 7. So when n is 7, we can go back and get the value of k. So k is going to be 14 over n, so it is 14 over 7, which is equal to 2. Therefore, k is 2, n is 7. That's how we find that value there. So this was question 8. So we're using Zoom, so we have less time. We can't start another question and finish it, since this is a new question. So what we'll do is we'll have to log out and quickly come back so that we continue. So here we won't wait long. So if you delay to come back, you find we are done with question 9. So let's do the logging out and coming back quickly.